So tonight's topic is clouds, and we'll get into a lot of the minutiae as well as the common stuff that most people already know about types of clouds and where they come from and such. But we'll also get into clouds on planets elsewhere in our solar system and clouds on exoplanets. So this is a member requested presentation. Joanne, thank you. It's not about internet or network-based clouds. It's not about smoke from burning trees and such, combustion, or volcanoes, and not nebular clouds, which are in deep space. This is the meteorological or weather types of clouds on Earth and its skies, or the skies of other planets in the solar system or exoplanets. This is an interesting picture taken from the ISS, and you can see all the various cloud types in a single picture. You can also see over here some high altitude winds that are shearing off the tops of these stratocumulus clouds. So why do we get clouds? Clouds are a result of atmospheric pressure, temperature, wind velocity, and gravity. If the atmospheric pressure is too low, the clouds will boil off as vapor and dissipate. If the atmospheric pressure is too high, they'll hang as low fog, so they'll hang low to the ground, and they'll be dissipated by solar heat. If the temperature is too high, only vapor forms, which dissipates. If the temperature is too low, high altitude below freezing, then ice crystals form and they can hang around a little longer. If it's sufficiently low, they'll collect too many ice crystals and you'll get ice falling as snow. If the wind velocity is too high, as I mentioned in the previous picture, the clouds will be blown apart by shearing forces. If the wind velocity is just right, you'll get what promotes clouds, which are swirling winds that are either coming up from the ground due to heating and pushing the water vapor up, or they'll be spreading out. That's like the flattened cloud tops that you'll often see. And if there's not any wind at all, any vapor that comes up and forms clouds will fall because gravity. You have to have enough gravity in order to have an atmosphere. If you have a small enough planet, it can't hang on to its atmosphere, so you wind up with Mercury. The boundary seems to be around like Mars size, because we know Mars has clouds. We know certainly the Earth and Venus have clouds. These are water vapor-based clouds. We know that even larger amounts of gravity, and doesn't necessarily need to be water vapor, they can be, hydrogen, methane, a number of other elements than just hydrogen and oxygen for water. So what makes up clouds? Well, predominantly clouds are water here on Earth. The vapor pressure and the temperature dictate how the water will appear. If it's vapor, it will be pretty much invisible, like it's really humid, but not so much so that it falls out as rain or condenses as water or fog or dew or things like that. It just gives you that wet in the air feeling. And if you get too much water in the air, it'll fall as rain. If it's warm, it falls as rain. If it's colder, it falls as snowflakes, or if it starts to grow a little bit, it'll fall as sleet. And here's a word, graupel. If you have snow that starts to gain in density but isn't large enough for things like hail, you get little tiny pellets of heavy snow, like little clusters of snowflakes, and those are called graupel. But if the ice gets denser and forms bigger chunks, you can have hail. And I found that there's a discrepancy on what the largest hailstone ever was. The consensus opinion is it's about 8 inches, but there are others saying, no, I took pictures of a hailstone that was 18 inches across. How did it land and still stay intact for you to take a picture of it 18 inches across? Because they're hard in the core, but they're easy to fracture because they're like a giant ice cube. And if they get captured by water or ice, Particulates can be in clouds. Dust and sand. The desert sand from Africa is carried aloft by winds and humidity from Africa to South Florida. And then in the South Florida high humidity, more water attracts onto the dust grains, and you get, how come the building's got an orange tinge to it? Well, that's the Sahara sand falling in dew and then sticking to the outside of the building. You got to go clean it up. But even if you have smoke, ash, or embers, they can be alofted by winds and be picked up by the water. And you have smoky rain, rain that when it falls on your car, it makes this kind of gray, smoky ash substance on your vehicle. And that's just clouds carrying particles. And then everybody's quite familiar with wind that carries seeds and pollen, but the way you get the seeds and pollen to be growing is by water vapor on the outside of them. So it's not dry seeds and dry pollen. It's the wind picks it up, but eventually the water accumulates on it. And when it falls out of the sky, now it can start to implant itself because it's got a sufficient water supply. And for those of you who have ever heard the old wives' tales of raining fishes and frogs, this is a real thing. What happens is insects, fish, and frogs, when they're at their smallest, meaning, eggs, can get lofted by the winds, wind up in clouds, and then the clouds go over areas. And since they're still in fresh water, these things tend to mature, grow. So it isn't that it's raining frogs, it's raining tadpoles, because they go up there as newly hatched frogs, which are tadpoles, and then they hang around in the clouds long enough because they're small enough that eventually they get big enough or the water drops them and you get raining fish and frogs. And then over in India, they're notorious for having blood or chemical rain. This is more biological than it is chemical. So it's not like a pollution plant or something like that dropping red rain. It's that the rain, the rain falls carrying small single-celled organisms that have red tinted innards. So when you get billions of these cells falling as part of the rain takes on a red color, and they're microscopic in nature, so it looks like flowing blood, but actually it's just many millions of individual single-celled organisms that have a red nucleus to them. But it's called blood rain. Then there's the chemical stuff that comes out of Antarctica, but that's different. That's from us. So here's that same picture from before. I've enlarged it, and you can see we have cumulus, nimbus, and cirrus. Those are the three major types of clouds. And you can think of the cumulus as the light, puffy ones. Nimbus are darker, grayer, heavier with water. And the cirrus are the higher altitude, kind of stretched out ones. Those are icy. Those are mostly ice crystals. And then you have the variance where, okay, if you just had cumulus that hung low, you would have stratocumulus. If you have cumulus that has like a thunderhead effect and it gets up to a very high altitude, those will be altocumulus. So you can have these strato for low and alto for high on the different types of clouds. And then you have combinations of clouds. You have, they're kind of like cumulus, but they seem to have a lot more water than your typical cumulus, and it's descending because of its weight. So they call those cumulonimbus. And then you have moving patterns of clouds. So you might have nimbus or cumulus clouds, but they're getting pressed together and moving in on an area, and that's where you get thunderheads. But then you have the oddball cloud formations. So mammatus, that's like real angry skies. It's essentially cumulus clouds that are being pressed together and they get bumpy on the bottom. Orographic clouds, these are cumulus clouds that are being blocked by typically a mountain range, and they will actually collect on one side of the mountain range and then flow over the mountain range to lower altitudes, usually down to a body of water, and you'll get these clouds that look like they're hugging the ground. The ground they're hugging is actually high altitude, and the clouds literally just being held back at a lower altitude and rolling over the landscape. They're following the contour of the land. Then you have lenticular clouds. These are clouds that would like to get to a higher altitude, like cumulus clouds. They want to be boiled up to a higher altitude. The problem is they've got counteracting forces, typically winds, above them that kind of bracket them from getting any higher or any puffy larger. And then you have, no, it's not chemical contrails, it's just contrails. These are when there's a lot of small ice crystals up in the upper atmosphere, and as the jet aircraft go through them, the heat inside the combustion chamber of the engine heats up the water vapor, and as soon as the cloud goes by, it condenses the crystals, and the crystals form clouds. So where are clouds found? They show up at a variety of altitudes, pressures, and temperatures, low enough that they form very high. So if you have low pressure and low temperature, they can grow up very high. If you have high enough pressure and high enough temperature, they can't rise up. They'll hang low to the ground like fog, usually condensing out into dew. You'll often have clouds hanging above bodies of water because that's the source of the water that they're lofting into the sky. So you can have lakes, oceans, Everglades, marshes, large, normal, natural bodies of water. But you can also have rain-soaked areas. I don't know how many have seen this, but if you're in a large parking lot in South Florida and it's rained a little bit, but not a lot, and the parking lot asphalt or cement was very hot, and then it rains, and the rain falls onto this very hot surface and then immediately starts to vaporize, and you get that daytime fog above a parking lot surface area that sort of rises up and just disappears. And that's in kind of a microcosm, that's how clouds form. But you can have clouds forming above rain-soaked areas. The Florida Everglades is notorious for this. The morning rain in southeast Florida comes in from the seashore. The afternoon rains come out of the Everglades. It's a matter of wind direction and temperature transitions. And I actually learned how to detect where the rain was coming from in the late afternoons from Fox Observatory. If the air, so if you have a rapid drop in temperature, you have a slight pickup in wind, and then you smell metallic like magnesium, that means the rain's coming in off the ocean. If you smell sulfurous, like muck beds out in the Everglades, the rain's coming in from the Everglades. And that gives you about a 5-minute heads up on it's about to rain heavy, close the roof. And that worked many times, but trying to get people to believe you can predict the weather on 5 minutes notice, it's just science. But as rain soaks even agricultural areas, large farmland, if the rain falls there and doesn't, if there's water on those areas from having watered the agricultural area, that water then gets hit by sunlight. It will evaporate the water and you get clouds over agricultural areas. It's not unheard of, but it's not common to see the complete path of water vapor going from the ground to altitude formations. This is usually something like if you have a large enough shopping center, you'll see a cumulus cloud at 20,000 feet hanging above the shopping center, and there's no other clouds anywhere around it because the rest of it's all more average temperature, lower water area, like residential area. So you see a shopping center has a cloud above it. I know. Next time people go out and they're shopping, they'll glance up from their like Walmart at the right time of day in South Florida and go, there's a cloud above the Walmart parking lot and there are no clouds around it. Yep, that's because it rained on the Walmart parking lot and now the water vapor is rising up into the sky. Okay, the dynamics of clouds. The majority of the dynamics of a cloud are by heating or cooling. So If it gets heated and it has a certain amount of water and the pressure is such, the cloud will grow. If the cloud grows along the direction of the source of the heat, the sun, it will move with the heat. Same thing as in the late afternoon, as the sun sets, you'll get a lot of clouds out over the edge of the solar terminator where it's hitting the ground, and they'll form there, and that causes a pressure differential, which causes the clouds to move towards the shoreline where there's different pressure. So you have the expansion and contraction. They rise and fall, and that will cause wind, which will move them. For clouds that have freedom of movement, as in South Florida, no mountain ranges in the way to stop it, you can have clouds form in one part of the country and move across the entirety of North America. And if you think about that, it's a great way to predict weather, because you can say, well, yesterday when it was over this city, here's what we got. And the cloud didn't completely dissipate, but there's some of it left, and the wind is moving in this direction. So tomorrow in this adjoining city, you can expect rain. And by the velocity of the cloud, since nothing's stopping it, that's its maximum speed, you can judge the time of day down to within about a half an hour when it's going to rain in that adjoining city. And then, as you saw earlier, the clouds being blocked by geography, they'll crawl over to seek a lower altitude and different pressure. And that's where they'll condense and fall along the shoreline. So a place that's notorious for this is the western perimeter of Africa as it meets up with the Atlantic Ocean. The clouds coming across will be stopped by the mountains and descend and condense as fog. And this dew, they're actually using as a fresh water source now. You hang out nets on frames with the right diameter of little plastic edges that will collect the droplets, and the droplets will cascade down 30-foot tall sheets of this mesh, and it'll collect water at the bottom. And when you have a number of these collectors and they connect together, you can actually have flowing water coming off of the collector nets every time you see fog. So that's how they're getting fresh water, initially for agriculture, because people are concerned about what they're going to be drinking, and drinking the water from fog seems to be a concern, but drinking the horrible water from the local city water supply out of the tap, that's, I guess, okay. And then how clouds affect weather. If you have clouds in place, that can reduce the amount of heating going to the surface, so it can disperse clouds. If you have ground with a higher temperature and then you have clouds over the top of it, that will concentrate the heat, sort of a mini greenhouse effect. But when you have atmospheric pressure changes, you can have clouds that will change their state from liquid to ice or solid, and you wind up with humidity, fog, rain, or sleet, snow, ice storms, or hail, or you get particulates coming in from other places, or you get your insects, fish, frogs, or blood-colored cells. So I'm not going to get into lightning. Lightning is the electrostatic discharge as clouds build up and overlap each other and move through the atmosphere. This could be its own presentation. I learned a new one this week, which is, I've always known about red sprites and blue jets. These are lightning that are above the clouds, not below the clouds. So when you see a lightning strike that looks like it's coming down, it's actually a teaser that the lightning actually goes up, and it goes up with enough force to actually blast out the top of the cloud where you can't see it. The ISS and orbiting satellites can see it, but that's where you get blue jets. And then collectively, even higher altitudes, you get things called red sprites. And this is the new one. I didn't know elves. When the sprites do their discharge, there's a large circular pattern where the electrical discharge, much like aurora, will ignite a flowing pattern of green. Elves, that discharge is kind of like an electromagnetic pulse circularly going out, and it forms a ring called an elf. So that may be a future presentation, just talking about lightning. So what about clouds elsewhere, clouds on other planets in our solar system and exoplanets. That top right photo there, that's actually clouds on Mars. They're very thin, they're very high altitude, but Mars has just enough gravity for clouds to form. Think about it this way. If there's no flowing water on Mars, there's obviously fog, condensation, and lofting of the water that when it hits the high altitude, lower temperature, it forms cirrus clouds. So you go to bigger planets, to the Jovian-sized planets, you get clouds of other elements, like just pure hydrogen, helium, methane, and sulfur compounds. So that second picture on the right is the south pole of Jupiter. Now the picture was taken in color because it was taken by the Juno cam aboard the Juno spacecraft. So yeah, you can have blue clouds and sort of muddy brown clouds, and depends upon the chemistry of what's in your clouds. And you can have little clouds that on a very large planet like Jupiter want to do their own thing because they're pressed in on all sides, so they have their own little cloud formations going on.
That's a true color picture of Jupiter?
The south pole of Jupiter, yep.
That's amazing.
Yeah.
Wow.
Well, when you put the probes out there with just the right amount of camera equipment, recent contemporary technology, you can see things that were never seen before.
Looks like a jewel.
Yes, but Jupiter has a fast rotation, so you can see that the more towards the middle latitudes are out around the edge. They're one chemical structure, but then you have the higher velocity ones spinning close to the South Pole, and they're all disrupted. They're all little like off on their own, doing their own thing, and they're a different chemical structure. And through spectroscopic analysis, they can find out what these clouds are made of. And as they look outward into the universe, they can find exoplanets, and they can do spectroscopic analysis of the exoplanet's atmosphere and determine, okay, is there methane? Is there hydrogen? Is there water vapor? And what we're finding out is planets elsewhere are just like the things that are happening on Earth. They get the same sort of elements, but we have yet to have a close enough image to actually confirm flow of the atmosphere on an exoplanet. Maybe when the Sagan Space Telescope is put up there in 2035, it'll be big enough to get us some good images of nearby exoplanets. So theorized by scientists that are of the planetary science discipline, when a planet is too close to its parent star, but it is sufficiently large with high enough pressure, you can have swirling clouds of volcanic rock. Essentially, it will be raining sand, silicon dioxide. If you take that up to another level of pressure and heat, you can actually have hot hail. So you think of hail as being these giant ice cube, ice balls. But if you're raining hot sand and you get the sand hot enough, it will clump together. And the same way that you get hail from snow and ice storms, you can get hot hail, which is thing like hail, but made from silicon dioxide. So you have, if you remember the old Flash Gordon movie, the merciless Ming, the emperor, had a button on his evil device that he attacked the Earth with, and there was a button called hot hail, which some of the science folks probably knew what that was, but it looked like little volcano chunks of hot rock. But yeah, theoretically, you can have hot hail. But the one that people really like are if you have vertically circulating material that is carbonaceous, carbon, and it heats up, rises up, and the carbon vapor condenses just like ice crystals make snowflakes. Carbon vapor will produce diamonds. So people are saying on Neptune, in our solar system, it might be raining diamonds. because it has just the right carbon substances in the atmosphere and just the right temperature and pressure changes to loft the carbon vapor up into the high altitude. And then when it collects into a carbon cloud and then it descends, it will be descending under high temperature, high pressure, which is how you take carbon vapor and make diamonds. So as soon as De Beers finds out how they can build a rocket to get to Neptune, they will probably take ownership of Neptune and not allow those cheap diamonds onto the marketplace, which will, lower the price of their diamonds. But it'll be interesting to see as we advance our propulsion technology, what new and different things we can see. So in conclusion, clouds in the sky come in several types. They occur at a variety of altitudes, pressures, winds, gravities, and transfer chemicals, particulates, and temperature around the planet. This is how you get like the hot side hot and the cold side cold to mix. Yes, there are things like the Gulf Stream and underflow currents that do the same sort of thing for the water level, but for the atmospheric level, the clouds pick up huge amounts of water vapor and move it from one place to another, which changes the temperature where it drops out as rain or snow. Clouds are interesting to observe. You can look at a cloud and go, what does that look like? There are force for weather changes, heating up, cooling down, and they can take water places. So if you have a desert area that receives 20 inches of rain, it can get all 20 inches of rain in a day, and then the rest of the year it's all dry because there's no cycle to build up the water vapor to create the rain again. And if you get too much rain, you can have things like monsoons, where the temperature and the pressure get to be just right, and all the clouds build up the water vapor and then just slowly drop it over multiple days, and you can get many inches of rain falling in an area. We've had those in South Florida. We just used to call it the rainy season, but the winds were always strong enough that they would blow the rain as sheet rain through an area. So the amount of time it had to drop rain was fairly slow. Very brief. But we had a sheet rain that arrived in Florida and didn't catch much in wind. And so it made a little mini monsoon over Florida. And then you can have deterrence from being outside, like it's foggy, I don't want to go out there, it's scary. You can have monsoons where just stay indoors, and you can have sleet, like hope you have car insurance, otherwise you're going to be sliding around on the road, or hope you have a lot of good car insurance because the hail can destroy your glass windows and dent your vehicle. And then you have the funny things falling from the sky, blood rain, insects, fish, fry, and tadpoles. So keep looking, keep observing, look for things. And when you find something unusual, let people know about it. And of course, lots of links. Okay, did I cover enough minutia regarding clouds?
Yes.
Good.
Yes. Thank you.
You're welcome. See, proof positive. If somebody has a topic, I have no problem doing research on it. I may know some of the stuff off my head, like the various types of clouds, but how you can have raining diamonds or raining hot hail, like I had to look that up and go, is that really a possibility? Well, if you get the right mix of things, yeah.
That's great.
Okay. Any comments or question before we start recording?
No.
Nope.
Okay, let me stop sharing.
That's you.
Move the pen and stop recording.